Welcome back, students. In the last lecture, I have discussed about the atmospheric refraction and many more applications of atmospheric refraction, why the sunset or sunrise is delayed, why we get the normal rays during the noon time. And in today's lecture, I'm going to explain you the scattering of light, how the light is scattered, what are the beautiful phenomena related with the scattering of light, the applications of scattering of light, the beautiful phenomena like the blue color of the sky, why the skies of blue color is related with scattering, why sunrise and sunset are of red color, and the sun at the noon is white hot. Why this is so? These kinds of phenomena are based on the scattering of light and the application why danger signals are of red color. These kinds of phenomena are related with the scattering of light. Let us discuss about the scattering of light. Suppose this is the light coming from any source and it hit the target or any obstacle. What happens? This light is scattered, this light is deviated in many more directions. This is the scattered light. Why this light is scattered? When this light is passing through the atmosphere, it strikes the particles present in the atmosphere, and the obstacle of the comparable size of the wavelength of light, that target, that obstacle scatter the light in different possible directions, and this bending of light is known as the scattering. You can write the definition. when light passes through when light passes through atmosphere, then after striking to the particles of comparable size of the wavelength of light get bends after striking. This phenomena is known as the scattering of light. Scattering of light. This was given by the scientist Lord Rayleigh. Lord Rayleigh gave the relation for the scattering of light, that is, the intensity of the scattered light is inversely proportional to the fourth power of the wavelength of light. Here I is the intensity of scattering, and lambda is the wavelength of light. You can say larger the wavelength, the important conclusion, you can say larger be the wavelength, smaller be the smaller be the or lesser be the intensity of scattering. Intensity of scattering. You got it? This is the inverse relation. This lambda is large, intensity of scattering will be small. If this lambda is small, then intensity of scattered light will be large. If this is small, this will be large. Lambda is least for violet color and lambda is maximum for red color. You must remember this thing. In the spectrum, V, I, B, G, Y, O, R. This is the Gaur spectrum. Here this is having least wavelength and this red is having maximum wavelength. Okay. So depending on the particle size, they present in the atmosphere whose wavelength is comparable with the size of these obstacles, what happens? That light gets scattered and we see the particular color only. First you note it, then I will explain the beautiful phenomena based on the scattering of light. Now what is the cause behind the blue color of the sky and why sky is of blue color? You have to explain. I told you, my dear children, that the spectrum is VIBGYOR. This is having wavelength maximum and this is having wavelength minimum. And the relay criteria is what? This is the lambda raised to power 4. If you take violet color minimum wavelength, it means its scattering intensity will be very large. And then if you take red color, its intensity is its wavelength is maximum, so scattering intensity will be minimum. But one more condition is also there to verify or to be this relation to be valid. One more important thing is there, the size of the obstacle, the size of the obstacle should be comparable to the size of light wavelength. So in case of sky, when we talk about the blue color of the sky, when light is traveling from the sky to the atmosphere, what happens? The most of the particles present in the atmosphere, they have the size comparable to the wavelength. Their blue color wavelength is comparable to the size of the particles. If this is comparable to the size of the particles and comparatively these four colors, the blue color wavelength is less. So the blue color is obeying both the factors, one the lesser wavelength, second the size comparable to the size of the particles present in the atmosphere. That's why the most of the particles are scattering only the blue color and we are able to see the blue color of the sky. So in the answer you will write, this is because of the scattering of light. Scattering of light, when light travels through atmosphere, travels through it, strike the particles present in the atmosphere, present there. These particles These particles are of comparable to the wavelength of comparable to the wavelength of blue color, and blue color has the lesser wavelength also. Hence most of the particles scatter the blue color, and hence sky color is blue. Someone can ask the question from you that violet color is having the minimum wavelength, so it should have the maximum scattering intensity. But why this is not scattered maximum? Why the blue color is scattered maximum here? Your answer will be that all the particles present in the atmosphere, they are having this size comparable to the wavelength of blue color. That's why instead of violet color, the blue color is scattered more. Okay, note it. Now next application is why clouds are of white color. What is the reason behind this? This answer is also based on the scattering of light. When the light, the clouds are very near to us. When light is traveling through the atmosphere, and in the atmosphere there are dust particles, water droplets, and many more particles are there, smog is there. So these particles are having the size which is not comparable to the any particular color. So these mixed obstacles, they scatter different lights. So all color of lights are scattered, and hence they merge and they give white color of the clouds. So you can write it as this is due to the scattering of light. This is due to scattering of light when light travels through atmosphere, when light travels through atmosphere and clouds are near to us. Clouds are near Earth atmosphere and have dust particles, water droplets, vapors, that is the particles of different sizes. That is the particles of different sizes. Hence, this condition is not valid. This condition is invalid according to Rayleigh, and light, all colors are scattered by different size particles, and cloud appears white. Okay. One more question you can write here. Why danger signals are of red color? The same answer. This is due to scattering of light. This is due to scattering of light. What happens? You know, the intensity is inversely proportional to the fourth power of wavelength, and the red color is, lambda for red color is maximum. So red color is least scattered. Red color is least scattered, and all colors get scattered. Hence they appears red, or you can say they are colored red so that it can scatter least, or the red color scattered least so that it is visible from the distant vehicle. It can be visible. Got it? And you can write one more application by yourself, that is why the sunrise and sunset are crimson red in color. Why this is in reddish color, you can write by yourself. With this scattering of light, this chapter is completed, and for any query regarding dispersion of light and the dispersion through the glass prism, atmospheric refraction, its application, scattering, its applications, regarding any question, you can call me or you can put your question in the comment box. And from the next class we are going to start new chapter. This is all about the refraction of light in different modes.